Hello everyone, welcome to your physics class of class 8th. I hope you all will be fine. Students, in our previous video we have completed 1 to 33 question answers of lesson number 3rd. Now today in this video we will complete the remaining question answers and also the numericals of lesson number 3rd. Okay, so let's begin our class. Question number 34. A dam has broader walls at the bottom than at the top. Give a reason. Answer: to withstand the greater pressure of water which increases with increase in depth. That's why walls at the bottom are broader than at the top. Question number 35. What do you mean by atmospheric pressure? Atmospheric pressure, the thrust due to atmospheric air on unit area is called atmospheric pressure. Question number 36. Write the numerical value of the atmospheric pressure. So the answer is 10 raised to the power 5 Pascal. Okay, this is 10 raised to the power 5. Next question number 37. We do not feel uneasy even under the enormous atmospheric pressure. Give a reason. Answer: blood in our body exerts blood pressure which is slightly more than the atmospheric pressure and we do not feel easy. Question number 38. Describe a simple experiment to illustrate that air exerts pressure. Answer: take a tin can. While having airtight cap, remove the cap and boil some water in it so that steam comes out, and in this way air from inside goes out. While boiling, replace the cap and allow it to cool. Vapors inside condense and form water, creating vacuum above them. We see the can crumbles due to the air pressure from outside. This proves that air exerts pressure. Okay, so this is a diagram. You have to make this. Now next question. Describe the crushing tin can experiment and what do you conclude from this experiment? So you have to take a tin with airtight cap, remove the cap and boil some water in it so that the steam comes out, and in this way air from inside goes out. While boiling, replace the cap and allow it to cool. Vapors inside condense and form water, creating vacuum above them. We see the can crumbles due to air pressure from outside. This proves that air exerts pressure. Okay. Next question 40. Give reason for the following. First one, a balloon collapses when air is removed from it. Answer: atmospheric pressure which is more than inside pressure of balloon causes balloon to collapse. Okay. Second, B, water does not run out of a dropper unless its rubber bulb is pressed. Atmospheric pressure acting from outside the dropper balances the pressure exerted by water, and water does not come out of the dropper. On pressing the dropper inside, pressure of water becomes more than outside atmospheric pressure and water runs out. C, two holes are made in a sealed oil tin to take out oil from it. Answer: two holes are made in a sealed can so that atmospheric air pressure presses the oil at one hole and oil comes out of the second hole. Question number 41. What does the atmospheric pressure change? How does the atmospheric pressure change with altitude? Answer: pressure at sea level is taken as 76 centimeter of mercury column, which is 1 atmosphere, but this pressure varies with altitude as density of air decreases as we rise up and air becomes rarer. For every 105 meter rise in height, pressure decreases by 1 centimeter of mercury column. Okay, so this is a graph that shows the variation of pressure with altitude. Okay, now we will do the numericals. First numerical, find the moment of force of 20 Newton about an axis of rotation at distance 0.5 meter from the force. So force given is 20 Newton and perpendicular distance is 0.5 meter. And you know the formula for moment of force is force into perpendicular distance. Therefore, 20 Newton into 0.5 meter is equals to 10 Newton meter. Question number 2. The moment of force of 25 Newton about a point is 2.5 Newton meter. Find the perpendicular distance of force from that point. So the answer is moment of force is equals to 2.5 Newton meter, it is given in the question, and force applied is equals to 25. Now 25 Newton. You have to find out the perpendicular distance. So as you know that moment of force is equals to force into perpendicular distance. So moment of force is 2.5 and force given is 25, and for perpendicular distance we have taken it as x. So x is equals to 2.5 divided by 25. Therefore we get the answer 1 upon 10 meter, or we can say 10 centimeter. Okay. Now question number 3rd. A spanner of length 10 cm is used to open a nut by applying a minimum force of 5.0 Newton. Calculate the moment of force required. Answer. Distance, perpendicular distance is equals to 10 cm, that is 1 upon 10 meter. Force applied on a spanner is 5 Newton. Moment of force is equals to force into perpendicular distance. Therefore, force given is 5 Newton and the perpendicular distance is 1 upon 10 Newton, and when we will solve this, we will get the answer 0.5 nanometer. Okay. Now next question. Question number 4. A wheel of diameter 2 meter can be rotated about an axis passing through its center by a moment of force or equal to 2 Newton meter. What minimum force must be applied on its rim? So diameter given is 2 meter, and so we will find the distances OP, that is 1 meter, because this is the perpendicular distance from the axis of rotation. Now the perpendicular distance is equals to 1 meter and moment of force given is 2 Newton meter. Therefore we will calculate the moment of force as force into perpendicular distance. Here perpendicular distance is 1 meter and moment of force is 2 Newton, 2 Newton meter. So therefore force will be 2 upon 1, that is 2 Newton. Okay. Now next question. A normal force of 200 Newton acts on an area of 0.2 meter square. Find the pressure in Pascal. So formula for pressure is equals to force upon area. Force given here is 200 Newton and area is 0.02 meter square. So therefore the pressure will be 200 into 100 upon 2, means we have changed this point. By removing this point we will get here 20, so we have written here 100 and we will get the answer 10,000 Pascal. Okay. Question number 6. Find the thrust required to exert a pressure of 50,000 Pascal on an area of 0.05 meter square. So pressure is equals to force into area. Force is equals to pressure. Pressure is equals to force upon area. Therefore force will be pressure into area. We will multiply this for pressure by area, that it will be equals to force, and we will get the answer 2500 Newton. Question number 7. Find the area of a body which experiences a pressure of 50,000 Pascal by a thrust of 100 Newton. So we know the formula for this pressure, that is force upon area, and we have to calculate the area. So we will arrange this and we will get the formula. Area is equals to force upon pressure. Okay. Force given here is 100 Newton and pressure is 50,000 Pascal. So after calculating we will get the answer 2 into 10 raised to the power minus 3 meter square. Now question number 8. Calculate the pressure in Pascal exerted by a force of 300 Newton acting normally on an area of 30 centimeter square. So force given here is 30 Newton, area is 30 centimeter square. So we have to convert this 30 centimeter square to meter square. So what we will do, we will multiply it by 10,000. Sorry, divide it by 10,000 and we will get the answer 30 into 10 raised to the power 10 minus 4 meter square, because here is centimeter square is there. Therefore we have to multiply it by 100 into 100 to get the answer in meter square. So force pressure is equals to force upon area. Force given is 300 Newton and area is 30 into 10 raised to the power 4 minus 4. So this we have written downside, so it becomes positive, this 10 raised to the power minus 4, and by solving this we will get the answer 10 raised to the power 5 Pascal. Question number 9. How much thrust will be required to exert a pressure of 20,000 Pascal on an area of 1 centimeter square? Therefore, formula for force is that thrust is force. So, formula for force is pressure into area. Pressure given here is 20,000 Pascal and area is 1 centimeter square. So, we will change this centimeter square to meter square by dividing it by 10,000. So, we will get the answer 10 raised to the power 4 meter square minus 4 meter square, and when we will multiply this, we will get the answer 2, means 20,000 divided by 10 raised to the power 4. So we will cut this 40 by this 40, and we will get the answer 2 Newton. Okay. Now next question number 10. The base of a container measures 15 centimeter into 20 centimeter. It is placed on a tabletop. If the weight of the container is 60 Newton, what is the pressure exerted by the container on the tabletop? Here the area of the base of the container is equals to 15 centimeter into 20 centimeter. We will change this centimeter into meter by dividing by 100. So we will get the answer 300 upon 10,000 meter square. And force equals to weight, and it is given here is 60 Newton, and we know the formula for pressure. Pressure is equals to force upon area. Therefore, 60 upon 300 upon 10,000. That is, by solving, we will get the answer 2000 Pascal. Okay, you all know how to solve these questions. Now question number 11. Calculate the pressure exerted on a surface of 0.5 meter square by a thrust of 100 kgf. So answer, how you will find out. Thrust given is, that thrust, that is force, is 100 kilogram force, and area given is 0.5 meter square. So formula for pressure is equals to thrust upon area, that is 100 upon 0.5 is equals to 200 kilogram force per meter square. Okay. Now next question. Now next question number 12. A boy weighing 60 kgf stands on a platform of dimension 2.5 cm into 0.5 cm. What pressure in Pascal does he exert? So force is equals to thrust, and that equals to weight. Weight given here is 60 kgf. We can change it into Newton by multiplying it by 10. Means kgf can be, for changing kgf into Newton, we have to multiply by 10. So we will get 600 Newton, and then area given here is 2.5 into 0.5. So this is also given here in centimeter. We will change this in meter, dividing by 100 by 100. So we will get the answer. On solving this, we will get the answer 1 upon 8,000 meter square. And we know the formula for pressure, that is force upon area. Force is 600 Newton. Area is 1 upon 8,000 meter square. So on solving, we will get the answer, this 48 lakh Pascal. Okay, you can write like this also, or you can simply write the answer till here. So now what you have to do, you have to complete this work in your notebook. Okay, and you have to learn these answers, and question answers of next lesson I will give you in the next video. Okay, thank you.